Hey guys, it's Coach Stricker again, and today we're going to talk about the kinetic theory of matter and how that affects the particles of a solid and a liquid and a gas. So it's basically the particle arrangement of matter. So we're going to start off with solids, and solids you'll see have a definite shape and they have a definite volume. So they have definite shape and volume, and solids particles have the least amount of energy. And you're going to see there's a trend going from left to right. So least amount of energy. And the solid particles are also, the kinetic theory of matter says that they're not free moving. They're basically just very, they wiggle or vibrate they don't move. So they are not free moving. And they're said to vibrate or wiggle in a stationary position. That's what I was thinking of. All right. There's two types of solids. There's amorphous solids. And amorphous solids are going to be like Play-Doh and plastics and stuff like that. And there's crystalline solids. And crystalline solids are going to be the ones that have lattices. And the lattices are going to be definite structures that help make up definite, like crystalline solids, like salt or sugar. Okay? They have what are called lattices. Right? And you're going to see that they're like, that helps with the rigidity of it. Okay? And that's a word that's going to describe a solid is rigidity. They're said to be rigid or hard. Right? And so how does that compare to a liquid? Well, a liquid has no definite shape. A liquid's particles take the shape of their container. So no definite shape, but they do have a definite volume. So you can always find the volume of a liquid. So they have no definite shape. They take the shape of their container, but they do have a definite volume. They have a medium amount of energy. We'll see that when we get to phase changes. And a liquid's particles, they are said to be flowing over each other. So they flow. So they are free moving. They flow over each other. So it's kind of like waves in the ocean. All right? And the words that describe a liquid, you've got fluidity, because they are fluids, and they are slightly compressible, which means you can compact them into a smaller spot, and it will show the property of viscosity. All right? Viscosity is the resistance to flow. So you'll see have a container of water, and water has a very, very low viscosity because it flows very easy. Oils and thick, syrupy things have a higher viscosity, which makes them flow slower. So that's why they use them in engines and stuff to help cut down engine failure. All right, so viscosity, slightly compressible, fluidity, all describe liquids. They have no definite shape, they have a definite volume, they have a medium amount of energy, and they flow over each other. All right, now gases, gases have no definite shape and no definite volume. So no definite shape and no definite volume. So gases are going to take the shape of their containers because they're going to spread out, and it's very hard to get the volume of the gas because it spreads out so much and because they're so small. They have the highest amount of energy. So when we see phase changes, it's going from a solid to a liquid and a liquid to a gas, you're obviously going to have the most heat in that because it has the highest amount of energy. Gas particles are said to be flying free. That means they are just spreading out and flying everywhere. Okay, they're always going to spread out as much as they can. They are also called fluids. So they have fluidity. They are highly compressible. So you can take a gas in a container and push it down with a piston, and take if you've got a big container of gas and you push that piston all the way to the bottom, you can compress a gas into a really small space down here. So they're highly compressible. The other thing about gases is they're used in like hot air balloons and stuff like that because they can hold a whole lot of energy. So that describes the three types of matter and how they are in the kinetic theory of matter. So solids are tightly compact and not free moving. Liquids are flowing over each other, and gases are just flying free everywhere.